Hello, ladies and gentlemen, and welcome back. We are still looking at the 2016 Galois paper, and we are on question number 2, and question 2 concerns Judy. Judy has square plates, each of them having a side length of 60 centimeters, as you can see noted here, and I guess down here as well. A plate is shanks decorated if identical shaded squares are drawn along the outer edges of the plane as shown. So they've got some squares, and they're all the same size square, and they're just sort of tiling the inner rim or inner perimeter of this tile. The diagram shows an example of a plate that is shanks decorated with 12 shaded squares, and we do have 12 shaded squares. And you can sort of see them in groups of 3 like that. Okay. So once again, we've got 2 light bulbs and a written, just like in the last question. This tends to be a fairly common pattern. And what have we got for A? Judy's first plate is shanks decorated with 36 shaded squares. What is the side length of each shaded square? Okay. So we can actually perhaps use this grouping technique to figure it out. Okay. So we'll get rid of the last question. I can draw a better square than that. Okay. So, we are drawing the squares, but they'll sort of cut the space up. And leave sort of a white area in the middle, and there's these shaded squares as they've got them. What we can do is we can sort of say, well, the same number of squares will be in this blue area as in this green area. It's just a sort of a symmetry argument, really, and same as this yellow. It's the same number of squares. Now, we know the total number of squares we're going to have. 36. And so by symmetry, each of these needs to have 9 squares. Okay, and each one of these little groupings. So how many squares, say, on a side? Well, there'll be 9 in here, plus this one coming from the purple group. Just like there'll be 9 in the purple group, and then you'll get 1 more on the side coming from this yellow group. So I can see, I don't have to reason that much, but a picture's good enough. You know, we can say 36 divided by 4 is the 9 squares that we're using over here. So 9 plus 1, 10 squares along a side, or along an edge. And we're told that all of Judy's squares are 60 centimeter by 60 centimeter. So what did we want? Did we want the area or just the side length? Side length of each shaded square. So 60 centimeters. The total distance, because all these squares here are identical, we just divide that by the number of squares. It's going to be 6 centimeters for each of these smaller squares. And it's a light bulb question, so if we're confident in our answer, we can just leave the 6 centimeters as is. Okay? So we'll get some space for B part. When a second plate is shanks decorated, an area of 1,600 centimeters squared is left unshaded in the center of the plate, so this part here. What is the side length, again, of each shaded square? Okay. So, well, let's draw the picture again, but we'll put a little more emphasis on the unshaded part. Now, did they say it's a square in the middle, or it will be an unshaded square, but did they actually say it, or do I need to justify it? I guess I don't need to justify it because it's still a light bulb, but they don't say it's a square, but again, you can make sort of a nice little symmetry argument. Because it's the same square, it's the same pattern over and over and over again. But yeah, this is going to be a square. So this is a square, maybe call it side length x. So it's x by x. And the total square here is 60. Or 60 centimeter by 60 centimeter. So 106, not 160, 1,600 centimeters squared is really x squared centimeters squared. And it doesn't take too long. Grab your calculator if you need to, but you can realize the unshaded square in the center is 40 centimeters by 40 centimeters. Now, how does that help us? Well, take a look at the squares. I don't know how many squares I'm going to need, but we can still imagine some of the squares being added in. Now remember, all the squares are identical, and we're interested in this side length S. Okay, and S appears, well, everywhere you want it to appear. But most importantly, let's go from the top here to the bottom down here. It's a straight line down. It's S, the side length of the small squares, the shaded squares that we want to tile with. X, the side length of the unshaded region, the unshaded square-shaped region that we just worked out is 40 centimeters, and then another S. So I can see that 2S, 2 times this side length of the shaded squares that we are using to shanks decorate, must be what the length left over when you take the 60 centimeter side length and subtract off the 40 centimeters. Well, that's going to be 20 centimeters. If you divide that by 2, you'll get that the side length is now 20 centimeters. Which is kind of interesting. Actually, I think we should get the... Or sorry, not 20 centimeters, 10 centimeters. I didn't divide by 2, I just copied the number. I was going to say that. I was worried. It seemed a little big. But we would get, one square up here, and then 2, 3, 4, 5 square, 2, 3, 4 along the 40, and then 1 down here. And we can actually now calculate that there's 1, 2, 3, 4, 5, so there would be 40 squares in total. They're not asking that sort of stuff, but I like exploring the scenario they set up. So we got the side length, it's 10 centimeters, 10 centimeters per shaded square. Alright, and now C part, the last bit. A plate is double shanks decorated if 2 layers of identical shaded squares are drawn along the outer edges of the plate as shown. The diagram shows an example of a plate that is double shanks decorated with 48 shaded squares. There's 48 of these little ones here. Alright. A new plate, we can see they're also still 60 centimeters, these plates. A new plate is double shanks decorated, and an area of 2,500 centimeters squared is left unshaded in the center of the plate. Determine the number of shaded squares. So it should be basically the same reasoning in B. I'm going to make it a little nicer because I have to explain myself. But I'll say something like, we can see by symmetry that the unshaded area in the center, I mean, it's the same thing I said verbally, but I'm actually going to write it down so whoever's reading knows that I know what I'm talking about. Unshaded area in the center is a square. Call its side length X. Okay. So we got the unshaded area. And then what I'm going to do is I'm going to draw just a couple little squares here. Notice that in the corners you don't get 1 square, you'll actually get 4 squares. So I'll just draw part of a picture. Okay. So this is X. I'm going to call... Oh, wait. Do we need the unshaded... Oh, no, we want to determine the number of shaded squares. Okay, so it's a little different than the last 2 questions. I need to be more careful when I read. It's a lesson I always struggle with. I always think I know what the question's asking, and then I go somewhere else with it. This was a real problem for me when I was actually doing high school level contests. But I'm going to proceed as normal, because if I know the side length of all these identical squares, I can figure out how many of them are on a side. And then we could use the same sort of grouping thing I did in the first question to count how many squares there are. So, yeah, okay, it seems to work. At least I've got a plan of attack, that is. Call S the side of the shaded squares. we see, and I'll use a little blue line to highlight, so I've got two S's, X, and then two S's. So 4 S's in total plus X should be the total side length of 60 centimeters. Okay. And we are told the unshaded area is 2,500, and that should be, well, it's an X by X square. I already mentioned it's a square up here. So X is 50 centimeters, and if I plug that into the previous expression, 4S plus 50 is 60, so 4S is equal to 10. S is 10 over 4. 10 over 2 is 5, so this is 5 over 2, or 2.5 centimeters. Okay, but again, we're not looking for the shaded square side length. We're going to use that. Okay. So then we can see that there are 60 centimeters over 2.5 centimeters, which should be 60 over 5 halves, so 120 over 5, so 24 shaded squares along a side. Okay, now I'm going to bring back my picture again. And I'll even just say something like group the squares as shown. So we'll go into these corners. The corners are sets of 4. And I'll draw a few on either side. And then I'll leave some dots to the imagination. Because, you know, I know there's 24. I could draw them all out. But that would be a waste of my time. Grouping the squares as shown, and no, I haven't grouped them yet. So we'll do the same thing we did before. Use some red here. If I can figure out the number of squares in each of these colored groups, well, then I can just multiply by 4. Because all these groups are the same. I'll put yellow down here. All right. So grouping the squares as shown, we see each group has, well, each group is 2 by, well, there's supposed to be 24 in total, but we come back by 2, so it has squares in a 2 by 22 formation. Okay. So each group has 44 squares. So the total number of squares for our double Shanks shading is going to be 4 groups of 44 squares each. Take the two 4 factors, that's 16. 16 times 11, 176. So 176 squares in total. Okay, and I got to use my grouping strategy from part A, and I got to use the side length and unshaded square style calculation I made in part B. And I explained everything. Clear diagrams, 2 very nice diagrams, I would say. And we're good to go. So we are actually halfway done our 2016 Galois. Yay us. The next questions are a little harder. They always get harder as you go along. Feel free to try question number 3 before I get to it. Or if you want to jump over that and jump right to question number 4, I'll see you there. But no matter what, keep on enjoying math, and I'll see you next time.